This is the help video for problems 14 and 15 from the Chapter 3 Quiz Review. Directions state, describe the transformations to the parent function y is equal to 2 to the power of x in parts A and B. In part C, determine if the transformations are equivalent. So let's look at A, number 14. If we're asked what is the transformation, well, we can see here that our transformation that's being applied is happening up in the exponent with our x. So when we have x plus 1, we know that that is going to be a horizontal shift to the left 1. Letter B, we have g of x equals 2 times 2 to the power of x. Well, this is like our a value that we're looking at here. So this one would be a vertical stretch by a factor of 2. And then letter C asks, is f of x equal to g of x? Well, if we take our f of x, and we say that's equal to 2 raised to the power of x plus 1, right? Remember, this can be rewritten as 2 to the power of x times 2 to the first power, right? Because when we add 1, right, it's like multiplying times the same base raised to the first power. So if we took that and we rearranged it, right, if we move that out in front, we would have our g of x, which is equal to 2 times 2 to the power of x. So yes, these two are equal. All right, let's go on to number 15. So we're trying to describe our transformations again. So when we look at h of x, it equals 4 times 2 to the power of x minus 2. So starting out here with our 4 is going to be a vertical stretch. Bambi is rooting for us. He wants us to do well. He sounds really sad, but he's really not. He's a spoiled cat. Yeah, don't say you're not. You know you are. All right, so let's look at the other part of that one, right? We have the x minus 2 up here, which means that we are going to do a horizontal shift to the right 2. All right, and I think we've covered all the transformations on that one. Let's look at j of x. It equals 1/8 times 2 to the power of x plus 4. So remember 1/8, right, when we're multiplying by a proper fraction here for our stretch factor, right, this is going to be a vertical compression. By a factor of 1/8. And then when we look up in the exponent here, our x plus 4, that means we're going to have a horizontal shift left 4. Now, is h of x equal to j of x? Well, we're going to have to play around with these ones a little bit here to see. So let's start with h of x. Let's try to get them both into the form a times b to the power of x. So if I have 4 times 2 raised to the power of x minus 2, right, we'll start out with this minus 2 part. I know that that's the same thing as doing 4 times 2 to the power of x. Then we'd say times 2 to the negative second power, which we know 2 to the negative second power is actually just going to be 1/4. So we've got 4 times 2 to the power of x times 1/4. And now we can actually multiply these together. Well, 4 times 1/4 is going to be just 1. So h of x, when we simplify it down, is really just equal to 4 times 1/4 is 1. 1 times 2 to the power of x, or 2 to the power of x. Okay, now let's see what j of x simplifies to. We've got 1/8 times 2 raised to the power of x plus 4. So again, let's do the part that's being added up here in the exponent. It's 1/8 times 2 to the power of x times 2 to the 4th. Well, 2 to the 4th is really 16. 16 times 1/8 is going to be 16/8, or 2. So we have 2 times 2 to the power of x is what our j of x equals. So the difference between the two, right, this one has a is 2, or the other one would have a is 1. Therefore, no, these are not equal. So our answer for this one would be no. All right, if you have additional questions on these ones, please make sure you reach out.